Welcome back, guys. Today we'll be doing CAPE Unit 1 Past Paper 2019 Question 3. It is a trigonometry question. Let's get started. So question 3 says solve the equation 5 sec theta minus 2 sec squared theta is equal to tan squared theta minus 1 for theta is between minus pi and positive pi. So when we're solving, we need everything on one side. So I'm going to carry the tan squared theta and the minus 1 over the equal sign, which is to the left. So I will have 5 sec theta minus 2 sec squared theta minus tan squared theta. So minus tan squared theta, and then I will have my plus 1 equal 0. Now, here I have tan squared theta, which can be changed. I can change tan squared theta based on the identity. Now, before I change, let's do a rearrangement. Minus 2 sec squared theta, I am going to write that first. So I have minus 2 sec squared theta. Then I'm going to write the 5 sec theta, but because it's positive, I'm going to have plus 5 sec theta. So I'll have my 5, this is a 5, sec theta. Now, for tan squared theta, we have an identity for this. We have sec squared theta minus tan squared theta equal 1. Some persons know it as sec squared theta minus 1 equal tan squared theta. Now, I'm going to carry the sec squared theta over the equal sign. So I'll have minus tan squared theta is equal to 1 minus sec squared theta, or some persons will have minus sec squared theta plus 1. So carrying over the sec squared theta, so it become 1 minus sec squared theta. So this minus tan squared theta, I can replace it. Let me remove that, because all of this will be replaced with 1 minus sec squared theta. So minus tan squared theta is being replaced. Because the 1 is positive, that's why I have a plus 1 minus sec squared theta. Now rewrite my plus 1 equals 0. I can do some simplification because I'm seeing sec squared theta minus sec squared theta and minus 2 sec squared theta can be grouped together and simplified. It's just like having minus 2x minus x from algebra. We'd say it's minus 3x. Same concept that we're bringing here. If I have minus 2 sec squared theta minus sec squared theta, it's minus 3 sec squared theta. Then I'm going to rewrite my plus 5 sec theta. Then add 1 plus 1, that will give me 2. Then we have our equal sign equals 0. Now I'm going to let sec theta be equal to a variable. Any variable, I'm choosing x. So wherever I see sec theta, I am going to replace it. Now sec squared theta is the same thing as sec theta all squared. So this is the same thing. So I will be replacing this sec theta. So I will have minus 3x squared, and then replace the next sec theta. So I will have plus 5x plus 2 equals 0. Now the next thing that I'll do is just to factorize. So AC method, negative 3 times 2, that's negative 6. And we need two factors that multiply to give me negative 6, but add to give me the center, which is 5. So the two numbers are minus 1 and positive 6. So I will replace the center with negative 1 and 6, attaching an x. So I'll have negative 1x plus 6x, or some persons will have negative x, that's okay, plus 2 equals 0. Now grouping, so I will put these into two different groups. What can I factor out of the first one? I can factor out minus x, or negative 1x for some persons. Now factoring out the sign makes it positive along with removing one of the x, so it's just 3x. Then I'll have plus 1 because I removed minus sign and the x. The next bracket, I can factor out plus 2. 2 is common, so what I'm left with is 3x plus 1 equals 0. So that means I have minus x plus 2, and then I have equals 0, since I'm going to solve, and 3x plus 1 equals 0. So solving, I carry the 2 over the equal sign, so it becomes negative. So I have minus x equal minus 2, and then multiply both sides by negative 1, or in other words, divide both sides by negative 1, you'll have x equal 2. For the next one, you carry the 1 over the equal sign, so it becomes negative 1. Then divide both sides by 3, so x equal negative 1/3. Now, after finding out what is the value of x, I will now resubstitute what is x, which is x is sec theta. So don't forget about that part. X is equal to sec theta. So I will be replacing x equal to, so where I have x, I'll replace it with sec theta. So I'll have sec theta equal to, but sec theta is the same thing as 1 over cos theta. So I will replace it here, and it's equal to 2. Cross multiply, so I carry the cos theta to my right and the 2 into the denominator. So I have cos theta is equal to 1 over 2. Now, the next one that I have before I complete the sec theta equal 1 over 2 is x equal negative 1/3. But x is sec theta, and I don't have to go further because I will get no solution for this. You'll get a math error when you try to find the angle. So in this aspect, you'll just have no solution. But the part where I can get a solution, which is cos theta equal a half, I will find the cos inverse of a half. And because it says theta is between pi and negative pi, when I find the cos inverse, it should be in radians. That's what tells me I need to have it in radians. So cos inverse of a half is pi over 3. But since it says take into consideration the negative side, then going into the clockwise direction, the other angle will be minus pi over 3. So cos minus pi over 3 will also give me a half. So the next question states, let fx equal cos x plus 2 sin x. Express f in the form r sin x plus alpha, where alpha is an acute angle. Now, r sin x plus alpha. Sin x plus alpha is actually a compound angle. So I am going to express this as the compound angle. So I have r sin x cos alpha, that's an x. Let me write it properly. Sin x cos alpha plus r cos x sin alpha. Now this, I will equate it to be equal to cos x plus 2 sin x. Now, comparing the coefficient of cos x and sin x. So, the coefficient of this cos x is 1. And we cross out that. So, what's going to happen is that we're going to have r sin alpha is equal to 1. So, we cancel cos x on both sides. Like we take in the coefficient. So, the r sin alpha would have been in front if we rearrange. And it's equal to 1. Same thing for sine x. We cancel out the sine x on both sides. So what is left is r cos alpha, and it will be equal to 2. Now, to find out what is r, it will be the square root of 1 square plus 2 square. So that will be root 5. Because 2 square is 4 and 1 square is 1. So 4 plus 1 is 5. Now to find alpha, I will say it's tan inverse of r sine alpha over r cos alpha. So r sine alpha is 1. So I'll have the tan inverse of 1 over r cos alpha, that's 2. So the tan inverse of 1 over 2 is 0.464 radians. Now, it means that the answer for this, writing in the form r sine x plus alpha, replace r to be root 5 and alpha to be 0.464. And this is in the form r sine x plus alpha. The next question states, hence or otherwise, find the general solution of cos x plus 2 sin x equal 0. Now, for cos x plus 2 sin x, that was done in the previous activity. It is the same thing as root 5 sine x plus 0.464. Now equals 0. Now, for this, I know that getting rid of the root 5, I would divide both sides by root 5. And, 0 divided by root 5 would be 0. So that's why for the next line, I am just going to rewrite this as sin x plus 0.464 equals 0. Because dividing both sides by root 5, I will still get 0. So this angle x plus 0.464, when I sine it, it should give me 0. So let's look at this angle x plus 0.464. Based on our knowledge for sine, if I sine pi, sine 2 pi, minus pi, or even minus 3 pi, or any multiple of pi, in terms of n can be any integer, positive or negative, that when I sine it, I will be getting 0. So I've equated to be equal to n pi because n represents integers. So whatever is that integer, say for example 2, then I'll put sine 2 pi here, and sine 2 pi would give me 0. So that is why I have n pi. X plus 0.464 is equivalent to n pi, where n is an integer. So when I sine n pi, whatever n is, it will give me 0. Now for the general solution, I carry 0.464 over the equal sign, so it will be negative, and so I'll have n pi minus 0.464, and this will be the general solution for this question. Now the next part asks to determine the minimum value of 2 over 2 minus f. Now r helps to get the minimum value, and I am going to replace f with the r value. R can be positive or negative, but for me to get the minimum value, I have to use f to be negative root 5. So if I use positive root 5, I will not get the smallest value. Minimum means I want the smallest value. So in order to get that, I would have to use a negative number, because once I use a negative number, 2 negatives there will turn to a positive. And once you have a large denominator, the number gets smaller. So 2 over 2 plus root 5 is actually the smallest value. That's what the minimum value. But we can also rationalize, but the question did not ask us to do that. So that is why I'm not going to rationalize this. But rationalizing means that I multiply the numerator and the denominator by 2 minus root 5. But in this case, it wasn't asked for, so I leave it as is. The final question is to prove the identity tan A plus B minus tan A is equal to sine B over cos A plus B. Now, I am going to look on my left hand side where tan A plus B, we know tan is sine over cos, so I can write this as sine A plus B all over cos A plus B. Now I'm also going to change tan A. Tan A is the same thing as sine A over cos A. So I've changed it. But in the numerator, I'm also going to change sine A plus B because on my right, I am not seeing anything with sine A plus B. So that's the hint to tell me I need to change this. This is a compound angle where I can change it as sine A cos B plus cos A sine B. Everything else remain as is. Now the LCM for this, where I have cos A plus B and cos A, will be just cos A plus B times cos A. That's the LCM, the lowest common multiple. Now I am going to find the LCM, meaning simplify. So I just remember, how did I get this? If I have a fraction, I would say the LCM for this is 15 because you say 3 times 5 is 15. That's the same scenario that's happening here. Next, you say 3 into 15 goes 5 times, so 5 times 1 is 5. So that's what I'll be doing here, where cos A plus B cancel. So all I'm left with is cos A. So multiplying cos A times sine A cos B, this part, and cos A cos sine B. So multiplying cos A, I will have sine A cos B plus multiplying cos A times cos A, that's cos square A. So cos A is being multiplied by everything in the numerator. Then I have sine B. The next part, I'll have minus cos A into the denominator. These cancel. So I'm left with cos A plus B times sine A. Now, sine A, cos A. Then I have cos B. Cos square A, I'm rewriting that part. So I have cos square A. And along with that, I will have sine B. Now, where I have cos A plus B, it's a compound angle that can be rewritten as cos A cos B minus sine A sine B. So the sine A that I have with the minus sign will affect all of this. So multiplying, there will be some sign change. So sine A minus sine A times cos A cos B will give me minus sine A cos B. And then minus sine A times minus sine A sine B will give me positive sine square A sine B. Here I can cancel these two. These will cancel. So I'm just left with cos square A sine B plus sine square A sine B. So I'm going to have this being written all over cos A plus B cos A. Now in the numerator, I can factor out sine B, that's common. So when I factor out sine B, I'll be left with cos square A plus sine square A in bracket. And this is an identity. The identity states that when we add cos square A plus sine square A, it is equal to 1. So this will disappear. Now, the numerator will remain as is, and you should be seeing that we have the answer. So this disappear because this gives us 1, and we have the identity, which is sine B over cos A plus B times cos A. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below.